A picture from one of my highlights points in career where I was at one of the biggest lignite mines in Germany. That was in 2016. But it was a really big eye-opening journey for me as well. So I thought it would be nice to use that as a backdrop in introduction. So she's already made mention of all of these, so I'll just skip that and head straight into the talk. So I've tried to structure the talk in 4 parts. One part is to draw on how we look at the future of mining. The next part would then be to focus a bit more on technology and innovation and various aspects of that. And I did provide a different set of topics for the third portion, but I will change that and I will just give you a case study of how we work through some of those aspects of mining innovation and how we look at the impact on mine design, future mine designs. And then the fourth part will be where we get to talk and check if I've confused you or you get to confuse me. So the picture on the left side on this slide shows you a 100-ton steam shovel. I don't know if any of you have come across an electric rope shovel, but that was in 1919. This was used for the Panama Canal construction. And the picture that comes on the right side is also a 100-ton 4100 XPC electric shovel, which started coming to the market about 2-3 years ago. As you can see in the 2 pictures, the only thing that separates them really is 100 years. And these machines look very much the same in the way they operate. You can also see that their capacities are virtually around the same point, but a lot has changed from the machine on the left to the machine on the right. And that's what we call innovation, because while you still have the very main frame of the machine being the same, a lot has changed around the machine. This machine on the right side is very fast, it's agile, it's solidly built, and you're talking about top-notch technology sitting in there. It's able to see all around itself. It's able to operate autonomously. And that is a huge change from what it was, but you can see the capacity virtually look the same. So with that, I step into the talk, and an interesting quote there from Peter Senge. Today's problems come from yesterday's solutions. So as we fix the problems of today, we're virtually creating new problems for tomorrow. The problems are many. The first one is that grades are declining. So as you can see from the 1840 all the way to 2005, the average grades of different metals and minerals are declining. That's a huge problem. Apart from that, the amount of waste that we need to move in order to reach the ore is increasing. So while the grades are decreasing, the wastes are increasing in terms of volume. And what you understand by that is that strip ratios are getting terrible. The other picture that I want to share with you is the fact that the depth of discovery of the metals themselves are also increasing with time. So as we edge into the future, you need to go deeper to find the same ore and minerals that we used to find. But not only that, the grades are dropping, and you need to move a lot more waste to get the same amount of ore that you used to mine. The final picture that I want to show to you is the fact that it's not across one jurisdiction, it's across many other jurisdictions. The other problems we have is that operations are getting increasingly complex. We have different types of fleets, complex, electric, mechanical fleet, and the utilization of these assets are dropping significantly because we have operator issues, we have mixed fleet issues, we have geology issues, and other issues that obviously relate to infrastructure and the location of the mines. From an industry point of view, some of the top mining house companies that are watching, like Ernst & Young, have listed 10 items that are risk to the industry. And you see on number 9 is innovation. Sadly, mining does not put a lot of money where its mouth is. We like to take a lot more from the ground, but we don't put as much effort into innovation as the other industries are doing. And you can see mining lags behind other industries. Even oil and gas is doing much better. This is a picture of an old mine, Bendover mine in the UK. And I'll show you a picture of that mine today. That's the picture of the mine today. If any of you have been to the UK, it's called the Eden Project. That's a beautiful place to be. I spent a whole day there and my goodness, it's just amazing what they've done to this old mine. If you look at this mine and what it is today. And this frames the mindset with which we're looking at mines from now on. The next picture I want to show you is a picture from the lignite mines in Germany, where they're using a very efficient mix of energy to power the mine. So you have wind, you have solar, and even on the old pits where they finish mining and they have lakes, they installed solar panels on the lakes. And all of that geared towards powering the mine. And this is a future mine design concept which is already in play in some uranium mines across the world, especially in Australia, where they mine the material in situ and do not have a lot of surface footprint for the mine. And so I went backwards to the mine design concept to tell you that we now have to use the legacy concept to rethink how we design the mines so we don't have a lot of footprint. We also want to design the mine these days so that we don't have a lot of waste movement. And we also have to rethink what we call value, not just net present value, but all-inclusive value, not just to the mine, to the people who own the lands, as well as governments and all other stakeholders that have interests in these mines. The other thing that we need to rethink, interestingly, is the way we use energy. So these days, we don't even want to have carbon energy in use. But while we generate a lot of carbon side effects, we want to be able to capture the carbon and also sequestrate the carbon underground. The other part, we want to run the machines more efficiently. So you talk about automation, you talk about people-less mining, digital mining, smart mining, whatever we want to call it. And the last thing that is framing the discussion around innovation these days is post-mining land use. So what do we use the mine for or the land for once we finish mining? I used to work in Takwa. I used to work in Daman. I used to work in Wasa Amenfi. Wasa Kropon, sorry. What is it called? Wasa mine, I think. And some of those mines, once they finish mining, you just see the pit line there. The legacy we leave behind is beginning to haunt us, and we're required to now rethink how we leave these behind and what can we do with them? So there are two aspects of innovation. One is where we're leveraging what we already have. We want to improve, we want to make things work smarter, faster. And the other extreme end is where we change and rebuild new capabilities. Ernest Young has presented this interesting picture, and I've put 4 examples of different types of innovations on the scale to show you how they sort of fit on the extreme. Load and haul automation, most of you know what it is to make load and haul work by itself, no people, or at least take the people from the machines and put them somewhere close to the office where they can see the trucks and loaders and operate them. Virtual reality in mining, these days we want to be able to see the mine before we get in there. We want to be able to make decisions into the mine before we interact with the mine physically. There's great engineering where we want to create the grade that we want. We don't want to accidentally come to the grade that is in the ground. So we try and create screening of the material at different stages of the process so we can get higher grades coming out early, take that out and throw a lot more waste on the dump and not carry too much waste out of the pit. The final part on the top right corner is where you have in situ mining. So now we're not moving the waste at all. We're not moving anything. We sort of differentially blast the material in the ground, and then we carefully pump what they call excipients, special chemicals into the ground, not just bad chemicals, but friendly, in quotes, chemicals that will leach the mineral of interest and then release that into pipelines that are pumped onto the surface. So it's less intrusive to the surface, but you still get as much of the mineral as you want. On the right side of this graph is what you call the technology gap graph. So like we just saw, the extreme part of leveraging what we have today and jumping to new technologies altogether is this gap that is an effect of the rate of change. So if we can change fast and radical and crazy, we sort of get a huge gap. If the change is incremental and time tempered, then you have just business productivity type improvement. And that's what we would often call business improvement on the mine. Now, what I've tried to do or put here is to then carry that concept that we had from the previous slide into this one, where we've broken that into 4 categories. And they're different. If you go online, there are different ways of looking at this. Some of them look like that, where they juxtapose value created versus change or rate of change. So if there's a lot of change and a huge value created, you call it transformational change. If very little or low change and the value is not too huge, you call it incremental change. Anything in between is a breakthrough effort. It's also the same picture shown this way differently. Sorry, I'm having to admit people into the meeting, so every now and then I'm sort of giving your attention. And then the final view is where you sort of look at it from the point of view of the market and solution. If it's a new solution and a new market you're exploring, then it's disruptive. If it's just the old existing market and the solution is not really new, it's existing, you're just improving, then you're optimizing. And you have the other extreme ends of extending the knowledge as well as adapting the knowledge. As this other view of the same thing. Now, when it comes to envisioning technology and innovation for the future, there are 4 key things that we need to be able to capture quickly at the beginning. One is accounting for uncertainty, and risk. There's a lot of uncertainty riddled in mining. One of them is the geology itself. So we drill sparsely, we get sparse geological information, and we make inference as to what deposit sits there, where the mineralization is. But sometimes this information is very incomplete. So unless you get more information, you could be working with very uncertain information, and that could easily affect your assumptions that you made on the geology. Things like appropriate value and cost drivers. So you need to be able to determine what lever you change and it affects the outcome on the innovation or the technology. The other thing is downstream, upstream effect. So yes, you decide to go for electronic blasting and change blasting because you don't want to have misfires and all of that. But that changes what happens downstream because maybe now you get a lot more fines and the plant doesn't like fines. Or sometimes they like it, but sometimes they don't like it. The other thing is that then you need to blast more accurately. You need to predetermine all your blast holes. You can't leave clogged holes or water-bound holes because you're dealing with electronic detonators and you're dealing with complex issues around blasting. So you need to be able to count both upstream and downstream effects. And the final part is that you need to be able to work through sensitivity analysis of various variables that comes across your estimate or evaluation. Now, often you would find that we use something called NPV, net present value. But underneath this net present value, most of you would know of iceberg effect. A lot of things that people fail to count when valuing technology. So at the end of the day, we try a new technology, but we haven't counted every single factor that needs to be counted. The technology comes in the first year, second year, it drops off, it doesn't work. We lose a few millions of dollars. We blame no one and we carry on as business as usual. And it's all because we fail to count everything that needs to be counted properly. At Mining 3, and that's probably one of the things I've brought to the table is that it's a very comprehensive approach to modeling value, and that's some of the work that I lead at Mining 3. This picture on the right side comes from Mining 3. So it's one of the projects we call the VoxelNet. And it's a 3D impression or creation of a mine, a block model. Many of you who would have played Minecraft will understand what this is. So it will become a virtual mine, and you would be able to enter into this mine, create designs, you'll be able to assign value and all the things that you can assign to the blocks and actually interact with the mine virtually before you actually see the mine in reality. So I just want to say it's not my picture, someone else's picture. So from a technology landscape point of view, so you would have noticed we're in part 2 now. From a technology landscape point of view, there are quite a lot of things happening in mining at the moment. One is alternative energy power usage, and there's automation. There's bulk ore sorting. So bulk ore sorting is where the material comes from the pit and we sort it before we even get to the processing plant. So you don't have to do that. So it creates a stream of high-grade material that is taken straight to the concentrate plant without having to crash and screen so many times at a crushing plant. There's also ventilation on demand. So instead of ventilating the underground mine completely everywhere, you put sensors across the mine and the airflow is controlled as and when people arrive at those portions of the mine. So that saves you a lot on money. And there's a lot of improvement on GPS sensor qualities and drone technology. And a lot of that is being used in mines at the moment for surveying, as well as slope and wall monitoring for geotechnical purposes. There are other technologies that are being used at the moment. So alternative power, and I'll talk to some of that shortly. Some of you would have seen things like SmartCap in Mr. Entry's talk last time. There's also equipment management. So these days we want to be able to manage equipment more effectively, either remotely or when it's manned by people. We also want to lean a lot on the data that we get. So improve the quality of data that's coming, and also use the data to inform how we approach the mining and mine real time. So at Mining 3, we have some of the projects we work on currently called measure well drilling. So you're actually getting real feedback from drilling as you drill. You don't wait for the records to come 6 weeks later. As you drill, it comes in and then informs how you mine at the face. It's one of the technologies I see very common these days. Everyone is trying to get to. Even in the lignite mine where I worked in Germany, there was a key focus. So they put GPS sensors on the machines that are mining, and the face is scanned in real time, and it informs how they track the movement of the ore horizon as they mine. 3D imaging is becoming much more improved because we're getting much more quality data. But there's something missing here that I'm hoping someone can pick up. I'll just give about 5 seconds to see, can someone pick up anything that is missing from this law? Okay, I'll call it out. So that is 3D printing, number 7. So, and modular equipment, and that's another focus of my work. So there's a lot of 3D printers out there these days. And these days, what it allows us to do is that we can prototype quickly. So we can, if I make an example of a mine design, I can actually print it out in a few minutes and have a look at what it looks like. What are the impacts? What are we talking about? Physically interact with an object because we can print them. And these days we're actually trying to print not just things made of paper and plastic, but we're trying to print metal parts. We're trying to print gadgets, and instead of going to the shop to look for different things or commission someone and pay them huge sums of money to create prototypes, we're using 3D printing to create prototypes these days. In Australia, there are new solar panels that are made from 3D printing. So you take it and print it, and you configure it, and you have solar energy in your home. What it means is that things are becoming cheaper, and because the gestation periods are becoming shorter, we don't lose time, and we can quickly prototype and try 60 different iterations and get it right, rather than pay for just 4 iterations, because we can't pay for 60 iterations. And feel free to log your questions in the chat as you come by questions. And I'm actually glad that one of the key improvements in technology is actually in Africa at the moment. So in one of the mines in Mali, quite close to where I used to work, there's the world's first automated underground mine that is underway. And you can see a picture of operators sitting in a central control room, but these guys are operating real machines down underground. What it means is that the safety factor is significantly improved, and these guys are not in a place where there could be a fall of ground event and they could die. The families are happier. And what it means is that you could try different things because the human person is not sitting in front of the ground. There's no blasting, there's no misfire issues, and therefore productivity could be higher. But it calls for a lot of pre-work. You've got to be able to map the underground mine properly. You've got to drill better to be able to create a more accurate resource model. If I can ask that you all kindly mute your microphones. So in summary, the issue of technology and innovation in mining is a confluence between three key aspects of mining. One is people, machines, next, and then finally the deposit. The interaction between these three components is always a subject of innovation and technology. So the more we can improve the interaction between the man or the people and the deposit, the more we can create productivity and efficiency and, of course, a better revenue outcome for everyone. But there are quite a lot of factors that impinge on these thinking processes. From a machinery deposit point of view, there's net present value. So the more we can mine this deposit faster when the prices are good, the better for us. There's a supply demand issue. So sometimes there's a China-US issue that suddenly creates a backlog of stockpile and you can't sell anything and the price drops. So there's that dynamics that is happening around mineral economics, risk management, as well as capital productivity. Capital productivity is where do I get a lot more for the money that I invest in CapEx or capital for buying the machines or for buying the mines? And you would understand that some of these mines are not easy money. Some of them are in the billions to create a mine. Between the people and the deposit, there are lots of issues: geopolitical issues, social economic issues, social environmental issues, social cultural issues, as well as ecological issues, social technical issues, and the likes. There's so many issues that affect how technology is accepted, welcomed, adopted, and how long it will stay on the market. So at Mining 3, there's something we call the technology readiness level. So it's a way by which we measure the technology we're working on and how ready it is to hit the market or to be trialed in industry. The first point of call is where we generate ideas. So we have different processes of generating ideas and we come up with, hey, that's very foolish. Oh, that's not sensible. Yes, that's really sensible. Well, we group all the ideas together into one basket and we start tinkering with them. At this point, all ideas are useful because sometimes ideas that start today may be foolish, but 2 years later, enabling factors have made it possible for us to relook at the same ideas again. The next stage is where we begin to check, and if you look at it from a medicine point of view, that's where we begin to create different mixtures. What mixture is likely to heal the disease? Which one can we apply to this situation, and which one is likely to work? Between that, we want to prove that it's feasible. Then the concepts are developed further and evaluated, and that's what I meant by valuing. And we select what is best, and we begin to prove the concept and demonstrate for people to see. At the lab scale, that's what we do. So we'll be doing that at the lab scale. So there's a little test machine on the table, and we play with that machine, and we can show that in this small size it works. That's what we often do in medicine with mice. So we test the medicine in the mice, and we've proved a concept, but we haven't scaled it up yet. So the concept demonstration is where we begin to take this out of the lab scale area and move it into a real test rig. sizable in real ground and tested. And this concept at this point, we will be doing human trial. If you look at coronavirus and all that story, that's where we are at this stage. And then there's a final part where the technology works, it's good, it makes sense, no side effects or minimal side effects. We've dealt with all those issues. At this point at Mining 3, we begin to transfer the technology to a commercial person who can actually market it, who can make it out there for the industry to use, because that's not our specialty. Our specialty comes from step TRL 1 to about 5, but beyond 5, we hand it over. So there are many different industries that will talk about TRL up to 9 or 10. Some go up the way to 13, but we stop at 5 and we hand over to potential commercial partner to create a real prototype for market purposes. The challenges are that there are many different hands that work on these things. So there's industry partners. At Mining 3, we work with both industry and research partners. And then once you're beginning to get into the commercial technology transfer stage where someone needs to create a product out of it, you look for supplier or commercial partner to take that on. From our side, that's how we work. The challenges with technology and innovation is that it takes a lot of time. And the time value of money changes over time. So while you're playing with the technology and trying to perfect it and make it good, the value of money over that time is changing. And that's why we always go to NPV as a decision-making point. The times themselves change. So what is in vogue today may not be in vogue 5 years' time. And therefore, we're always pressed with time, even though we need time to do the work. Innovation takes dedication. So every day you hop up into the office, you get into the lab, you have a look at stuff. Sometimes you get no single idea, no new idea. But as you tinker with the idea, you play with, okay, what if I try it this way? What if I do it this way? What if I take out this factor and improve this other factor? Suddenly you come to a point of, hey, light bulb moment. It takes a lot of flexibility. So you can't say because I was thinking this way, I keep going that way. Sometimes you've got to say, okay, I think what I was thinking was really, really wrong, or it wasn't working. Let me try something else. And it therefore means that you've got to go through multiple attempts to come to the final outcome. Sometimes there's no outcome. Sometimes you have to give up now, and 5 years later, you find, the cost of battery is cheaper. Now I can do that. So there's a suggestion that it takes up to 30 years for a new technology to be uptaken. And Thomas Edison shows that a lot of the other technologies, electricity, solar, and all of that bears witness to figures around the 30 mark. It's not always the case. Sometimes it's 2 years, sometimes less. Sometimes it's just 1 day. Sometimes it takes Corona to make it happen within a year. But usually has a long gestation period for significant technology improvements. As you can see, there's up to 9 TRLs here, but we would often stop around the 5. Now, some of you would have seen this over and over in different types of shapes and forms. There's usually innovators. So we are, you call Mining 3 and some of those, the innovators. And we will often partner with early adopters to try the technology on site and see that it's working. And then there's, as soon as it takes off and there's commercial business, then you will have some early majority taking it. And then there's a late majority that will take it. And finally, the laggards, those who said, oh, it will never work, it doesn't work, it will always fail. Once everyone has bought into it, then they also get it. But by that time, the technology is almost dying. It's reached its maximum potential, and something new is appearing on the horizon. There's this little corner here, which is often called the trough of disappointment. And this is where the early adopters picked it up, and suddenly all the expectations were dashed because there were issues that were not understood very well at the time. And I'll cite one example: the Bitcoin and the cryptocurrency market is one of them. Look, it was top issue. Everyone was buying into it, and suddenly it dropped from whatever price it was, 7,000, 21,000, to nothing. And all those who put money into that were dashed. But it doesn't mean it's dead. In a few years' time, you see it comes up again, but this time people have understood mistakes, they've fixed the problems, they've tethered with issues properly, and now you would have a technology that works. And everybody, or the early majority, now heads up for it, and then everyone else begins to join the bandwagon. And Mining 3, I'll just show you some of the things that have come out of Mining 3. The Smart Cap, which was talked about by Mr. Henry MP last week, is a product that's come out of Mining 3. We have something called the cave tracker. So in cave, underground cave mining, where you can't see the ore coming through, but you want to be able to predict what you get at the end. We have these sensors that are dropped into the ore, and they flow down with the ore, and that, because you know where the sensors are, you are able to tell how the ore and mineralization is flowing. There's a new one that I'm currently working on, and at this point we're still in the mid TRLs. It's called the mechanical cutting tool, the one on top here. So instead of blasting, we would like to be able to cut the material. And this machine is proving to be a very good one, because it means we're not blasting. And in places where mining becomes very sensitive environmentally, we would use such a system to achieve that purpose. So because I'm running out of time, I'm going to jump some of these slides. This is a bit on Mining 3. These are examples of some of the projects we're currently working on. Just examples. There's lots and lots and lots of projects we're working on. And at this moment, some of them may seem very blue sky to you in terms of nearness to the current stage of mining, but a lot of them are already becoming test cases, and very soon you might just see some of them at your mine or in a mine where you are working. And I brought this up, square pegs and round holes, to say that when it comes to innovation and technology, doing it well the first time really counts. So if you need to take your time and do it well at some marginal expense, is better than to do it haphazardly and later on lose out on the value. And the one on the left is SD11 mine in Brazil, where they have 4 of these mobile crushing systems on conveyors instead of trucks. And it works well because it was designed by a mine in Germany, the biggest bucket wheel excavator mine in Germany. I worked there, was it 2016? And these guys know their stuff. So they have planned, they've trained the staff. So Brazilian workers were taken to Germany. They spent weeks, actually met with some of them. They spent weeks on training before they even put the technology out there. The one on the right, in a mine where I also worked, they tried the technology, they put it out there, but they failed to pick on things around geology, and sadly, the geology was not understood properly, and that affected a lot of the function of the machine. at the end of the day, they had to go and put it somewhere on a waste dump or so, or the stockpile, and feed it with the dozer. So therefore, the value that was proposed is lost. That tells you that if you place the wrong technology into an old mine without really thinking about the whole value stream, you might easily lose out. I just picked this example to show you some of the things we've worked on. And this is an autonomous haulage system we're currently working on. The benefits and challenges, I'll leave that out for now. So currently there's technology that allows buses to drive to a bus stop, and they connect to a charging system, and the battery is charged on the bus. So the bus travels on the battery, and it doesn't have to be connected with cables. So there's that induction pack that allows it to just, it grabs onto the bus and then it charges for a very short time and the bus is off. This technology is now available. So, and ships also use it at the moment, barges and are using it. And so we set out to build one. So that's version 1 of our system. And you can see we went for proof of concept. The size of the truck is 100 kilograms, and it's able to tip in all 4 directions. It does not have an operator. It's remotely controlled, and it travels on induction lines. So that as it's traveling on the lines, it's charging at the same time. It will interest you to know that it was done by students. So students spent 4 months with us, and this was their project. And so I'm just bringing this up to show that students can really be involved in all aspects of technology and innovation, and not just think about their pay pockets and money that they get from vacation training only. It's a whole paradigm shift in the mind to do new things. And we can do this talk again. I think this time is a bit too short for the content. I just thought I might still put your minds and interest for maybe future discussions in specific areas. The following year, we went on to building the induction system itself. And again, you can see students were involved. So we picked another crop of students. These are mechanical, electronic, and mechatronics students. And they build these things from scratch. They take a wheelchair, motorized wheelchair, they strip it completely zero, and they begin to build the components, build electronic components, they test it all. And that is where students make a huge impact on technology innovation. I'm just trying to stir some of you up who are thinking that way. Don't feel disappointed. Look for a very nice avenue where you can get involved. And it's actually good. So once we've done this, we go into the part where we begin to understand the value for the mine. What are the advantages? What are the disadvantages? And then we go into concept design now. So we start some concept designs. Okay, that's a pit. That's the hauler, 15-ton capacity. What if it traveled along a parallel line, no operator, nothing? And it's now you can increase the whole grade by 10% more. So it's now 20. And it can travel in excess of 40 kilometers per hour. There's a lot more that is here to speak to that. The advantages and disadvantages are all listed. So while you are thinking good stuff for the technology, you also need to think the bad stuff that could happen. And all of that together comes to define what value you get out of it. So we built a test case, that's a base case. We run the numbers, and this is done using discrete event simulation. Very interesting piece of work. And this is the case where we're using our new system. So you see, we're not only designing the system, we're beginning to value the system and determine where will the problems be. So you can see this is 6 777 trucks. But in order to replace 6 777 trucks, you need to have 19 of the 50-ton trucks. That's a lot of trucks in one pit. So you're beginning to think traffic management, traffic intensity, productivity. But you still see that overall, after all the assessment that we did, the electric haulage is much better because you don't have people operating the truck. And the productivities are better because you have average cycle times of 6 minutes as compared to the 17 minutes that you have for the 777. And on top of that, you're talking about four-sided loading and tipping, so the mechanisms are really improved. The other part of the work that I've had to do is also look at the impact on mine design. So we've taken this original design, which is the red shell, the green shell, which is meant for the 777. And we say, okay, we change the ramp distance, we change the grade of the ramp, and we change the width of the ramp because we have smaller tracks now. And then we run the numbers again, and you can, as you can see, by going to the smaller tracks, we actually get to mine deeper. We also get to steepen the pit a little bit, so we actually mine a lot more ore, and so resource utilization is much, much better. Apart from that, the unit cost is also different, and I'll just show you the ton grade curve because I'm hitting my ton now. And as you can see, the graph, which is in the yellow outline, is the one for the 777, and the one in the orange outline is the AEH, or the autonomous electric hauler. And as you can see, the grade drops for the smaller trucks, but overall your resource utilization is more because you actually mine more gold out of this pit than you would have mined in the 777. As you can see, I've really hopped on the slides because the time isn't much, but the content, I think, is enough to stir your interest for a lot more discussions in the future. So at this point, I'll hand over my talk to the moderator, and we'll go through the question and answer stage. I've seen a lot of questions here, and it doesn't look like I'm able to answer all of them. But let's get ahead with that. First one says, since the technology and innovation keeps on advancing, don't you think in the future humanity and the engineering discipline will be competing with newly and already made technology for survival and recruitment at the industry? Okay, so that's a question that is always coming up with automation. To say that once you're beginning to automate, you have robots out in the pit, but the robots need to be manned by people. So it will call for a different mindset. It will call for different types of engineering. And I'll probably say, for instance, the School of Mines here in Queensland, where I did my PhD, they've already changed their business model for the degrees. So currently, all engineers will have to do the basic mechanical civil, first year to third year. And in the final year, you get to master in mining or mechatronics mechanical. So what they've just done is that they've changed the mix. Now, civil engineers can work as civil engineers, but they can also work as mining engineers, and they can also work as mechatronic engineers. And it changes the mix of engineers that we get coming out, because the mines are saying, we don't just want pure mining engineers. We don't just want pure mechanical engineers. We want people who can jump from the plant to the mine design and plan. That will have its own negative effects, but it's trying to meet the needs of the future, if you would agree with me, for lack of better words. With that said, how do the engineering students and the new graduates without any jobs? So you will always have jobs, I can assure you that. And sadly, what happens with the boom and bust cycle is that when the cycle goes down, we reduce the number of intakes. I'll tell you, for instance, that in the department where I used to be a tutor, so I know this. The engineering students used to be over 100 for mining. Over the last 2 years, they only had up to 8. Only 8 mining engineering students. Who is going to fill that gap? So there's always going to be a job for you, but you've got to be able to have a mindset that is not locked into, I want to be only mining engineer. Until now, I never knew that I could be a practicing mining engineer and still be a researcher until I was in Germany. I got to the mine site and all the heads of departments were here, doctor. So that's doctor, engineer. And I was so baffled. I said, wow. So you can actually have people who work on site who are doctors. And well, that's what I want to be. I don't want to be a lecturer per se. I want to be the guy who is on the mine, who is able to dig into problems, who is able to innovate myself. I think there's a lot of stuff out there that we don't even know. It's possible as a mining engineer, as a mineral engineer. You think all you have to do is to process minerals, but that's not it. Some of you would have to end up in laboratories where you're playing with different assay chemicals that would change, it will revolutionize how we process mineral. I've been exposed to a lot of things that I never knew could happen for me. And the journey that I've had all through my career has actually built up to that. So I started as an explosive engineer, site superintendent at Wassa Mine. And I've gone through different things. In the UK, I did different things. In Germany, I did different things. In Australia, I did different things. In Tanzania, I did different things. In Mali, did different things. But now, when I look back and I look at the work that I do, I even did work in Savulugu Nantom with World Vision as a hydrogeologist. And so it all comes together, Gushegu Karaga, and some of those places that no one ever goes, but we learned on vacation. That's what I did in my vacation. How do you call it? It's this vacation thing we do every 3 months after a semester. Anyway, next question. May I know how an innovation mindset could be improved and developed? Okay. So one, there are people that need to be open-minded. You have to be open-minded. And the first point of call, I would say the Chiu Baba lifestyle needs to go. It's a terrible lifestyle to have in a university. Unfortunately, that's how our universities are set up. Chiu Baba, pour, pass, and go. So you have a wonderful first-class student who can't think out of the box. And sadly, that's why we will have an expert engineer who is just 1 year out of university from here, and he becomes MD on site in Ghana because his mindset is open, and it just takes him 3 months on site to understand the problems, to understand how to fix it. And usually the soft skills are really, really good. So they know how to get people to do stuff. And we sit there and worry about position, and I'm the MD, and I'm the mining manager, and I'm the that, and I'm the that. All that you really want is people who are solving problems, who have open mindset. Of course, the pay is good, but an open mindset is a good one. and a mind that is always searching. I look at the assignments that we do in university in Ghana, and I look at the assignments that I present to my students here, and it's very different. You know, the assignments here, you can't baba and pass. It's impossible. In Ghana, I know people who can give you every single sentence of the answer on the paper and they pass. Anyway, let me leave that story for some other day. A good mentoring is good. So finding a good mentor in industry and heading straight to industry is really, really, really good. There's no problem with people who want to do PhD right away, but sometimes it can cripple your progress. It can cripple the way you think around problems solving. So I would suggest that anyone who still wants to do PhD and all that should seek opportunity to do some practical stuff early, and then you can head off, and it actually helps your mind tinker through problems a bit better. Question I have here from Mohammed is that what kind of technology innovation is being put in place to make core logging and sampling very easy and efficient to boost the geological survey of prospect sites? Okay, I'll tell you what is out there and what we are even working on. So one we're calling measure while drilling. So what you want to do, you don't want to bring the core out broken in pieces and all of that before you even try to understand it. What we're trying to do is to understand the rock as you drill it, and it informs you not to just drill one straight route that you're already drilling, but change your path. Don't keep going that way. Change the direction, because it looks like you've just missed the ore. Drill leftwards. And we have technology currently ongoing for directional drilling. We also have technology that is able to characterize the rock material as you drill, so that you are not bagging into samples, taking to the geology assay lab only for people to confuse the samples, but you can actually do on-the-spot tests on different samples and quickly log that quickly. And also there's also technology that is trying to be able to keep the core samples intact, so they're not broken into pieces extremely before they get used. Felix says, what skills do you think is needed for innovation in mining and planning and design? Yeah, so that's what I talked about. So open-mindedness. So a lot of the engineers start off as track and shovel engineers, and that is all they know. That's all they want to think. I remember, I still have a bit of time for answers, so I'll give you an example. So in one of the mines where I worked in Mali, there was one time I was doing all my pit designs, and there were two pit designs that were next to each other, but there was a huge gap between them. And as I did the design, and my geologist was Ghanaian too, and he was called Mohammed, sadly passed away years later. But I went to him and said, hey, can you give me both the grade control resource model as well as the grade control and resource model together? Because I don't understand how we could have two rich pits next to each other and there's nothing in between them. So I took this resource model, loaded up the two pits next to each other, and then I began stepping through the resource model bench by bench. And as I did that with the combined resource model with the grade control, I found that there was actually mineralization between the two big pits. So I went to my chief mining engineer and I said, hey, I think there's gold here. And at that time, we were actually short of ore for 3 months because a place where we thought had a lot of ore did not have ore. And my chief mining engineer said, "Oh, Isaac, I think these geologists understand the deposit. So I honestly think there is nothing there." So I took the files home, and in my own time, I designed the pit. I designed everything ready for mining, and then I kept it. Then one day I was sitting in the office, that was a month or so later, and the tech services manager came over and said, "Isaac, we're having a crisis meeting. Would you like to come join us?" And this is a meeting with MDs and others, and I was a bit scared. What have I done this time? And they said, "Isaac, you designed a pit for this portion. Can you take us through, can you give us a presentation of this pit?" And I was already shaking. But because I had already done the work, I honestly believe, I was convinced of this, no two ways about it. So I presented to them and they said, "Okay, Isaac, are you sure we can mine this?" I said, 100%. If you take machines out there this week, you will start mining this pit. There was a lot of discussion. So they sacked me out of the room as usual. I mean, had their meeting, and then later on they said, "Isaac, you lead the charge. We'll get this pit mined." And for the next 3 months, that is the pit that saved the year. And I'll tell you, they didn't even name the pit after me. They named it after the vice president of the region. But I didn't care because I thought for the first time I was happy with something I had done in the quiet. So having an open mind is really key, and not shutting yourself to, the surveyor said this. Did you check it yourself? Did you just investigate it a little bit more? They said this place is hard, so we can't mine it. Ask yourself, this level is soft. The next one they said is hard. This other one is also soft. No, there's something unusual here. Let's explain it. Geologists, let's help me. And look, you'll come across people who will not cooperate, people who would pour ice cold water on some of that fire and energy that you have. But you can't shut yourself down. You've got to be able to be open and ready for a bit more. Look, I have good experience. I have exposure. I've been expert from a very early stage. But I'm still pushed to do a PhD because I think there's a research mind, there's a mind that searches when you are able to understand the basic research skills. And so I still did it, even when it was a bit hard. I had to do it full time, even though I was working full time. But yeah, it's just a mindset, just a mindset. Let's see. Francis said, very enlightening. Thank you, Isaac. Rethinking known technology must be our buzzword. Yes, not just known technology, but also technology that is unknown. So, the very simple technology in the backyard, in your grandmother's yard, in something that mom is doing that you have a look at. Why is she doing it this way? Why is the charcoal? I saw a charcoal video recently, Dzakpata or something company, and that is someone asking questions. And why doesn't the charcoal burn? Why? And that mindset always breaks through. It always breaks through. Thank you very much. Sorry. I have come across a number of projects that used AI for prediction of spatial distribution of minerals in an area with the goal of cutting down exploration drilling costs. Some of them performed really well and their mineral estimation accuracy is good. Do you know of any such? Yeah, so we have some of that too, but AI is bigger than just the one thing, and sometimes another aspect of AI can just change the whole thing. For instance, we have this new thing around fiber optics that is able to use acoustic sensing technology to differentiate between minerals. So and use it to monitor conveyors. You can see that on the Mining 3 website. And it's going places now. So it's just a fiber optic cable that is put on the ground or put maybe through the drill rod. And as it drills, it's able to pick sounds from different types of minerals as it mines. And imagine that you can use that plus your spatial distribution to be able to predict more effectively. So there's a lot of AI things out there, and sometimes putting them together could actually create the precise technology that you're looking for, innovation that will help to improve some of these things. And it's still just the searching mind. I must point out here that one of the limitations of our search engines in some of the countries is that it doesn't allow us to see certain things. So I could tell you for a fact that as soon as I hit Nottingham, UK, my very first Google search gave me things that I could not believe that students had access to that. But our unis and universities need to begin to pay for very comprehensive databases that allow students to search and find good library material, good informative stuff, access to journal libraries. And I would encourage all of you, because you're members of OZIME, you do have access to a library called a One Mind Library. That should be your go-to place. Anytime you need stuff, go search this library because it has literature that you will never find even in university libraries. Anyway, who's that? So in Infinix Smart, it would be nice if you guys use your real names because that makes it easy to reference somebody, but Infinix is cool. Frank Techi says, if you were a mineral engineering student in your first year in Ghana, would you have done or studied aside your normal college syllabus? Indeed, if I have access to it. And let me tell you that for some people who do the degree, some people don't get first class, not because they are not smart. Some people do not get first class because they try to understand the content. And some people who get first class, they get it because they really understand. That's good. But not everyone who does not get first class is a bad student. And we should stop that mindset, because the guy who did not get a first class can also be a very, very good innovator. And we should encourage that. Some people are, they find the aspects of learning that suit them best, and there's aspects of learning that do not suit them. But all in all, there's opportunity for everyone to become a master of something that they do very well if they have an open mind and they're prepared to be problem solvers. I think we still have 4 minutes for questions. Any other question? I'd like to have a question by audio if there's one. If anyone has a question that you want to say out and not type out, I'll be happy to hear that.
Yes, sir. Hello, sir. Hello, sir.
Yeah, carry on. Everyone can hear you.
This is Emmanuel. Yeah, I wanted to ask this question that, please, is there any mine design that could help to, let's say, produce all material that could pass through a secondary crusher without passing through a primary crusher?
Yes. Yes, so currently, and I spoke to one of that earlier on, it's called grade engineering. So So what we've done is that because we understand the geology, we blast preferentially. So with the ore, we blast well because there's an understanding that in some certain mineralization, the ore sits better in the fines than in the coarse material. So we blast preferentially in the ore, and then right on the bench, we do screening. So we pass the materials through screens, and then it separates the fines from the coarse material. So right on the bench, we've just separated the concentrate fine and sent straight to the concentrator and just process. So it doesn't go through the primary crusher. It doesn't go through secondary crusher. The other components which are coarse but still have maybe some mineral by grade engineering will then go through, say, secondary crusher. And then we decide, look, there's not any use trying to crush this big rock because we've taken out 60% of the ore already. That's great engineering. And you can read about this with the CSIRO website. Is that helpful?
Okay,
Emmanuel, was that helpful? Hello, Emmanuel?
Yes, thank you, sir. Thank you.
Okay, that's good. I think I can take one more.
Hello, sir, thank you.
Audio question, that's all right. I have a question here by Felix. What specific technology skills would you recommend that every mining engineer should have aside the normal traditional skill? I think there's no normal traditional skill. It's thinking about what's going on there. You have deposit, you have people, you have machines. You want to interact with these three things in a way that is always optimal. So you need to always think about what you've just done with the design and make sure that you are making the most of all three assets. And so not just design it because that's how we design track and shovel mines. And mine design is not just the shell of the pit. It's thinking through how you actually beneficiate from all the mineral that is in the pit and do it smart and more efficiently. Design shift, time utilization modeling. One thing I feel would be useful for many of the mining engineers is to actually understand the subjects that they do, especially in the second and third year. The first and second year are very good, but I also understand that sometimes the way they are presented by lecturers can be very difficult to want to understand. So try your best to understand those, but the third and fourth year courses, you need to understand the courses for what they are, not just chew through photocopy documents and present an answer that passes, but you yourself do not understand the course and the subject matter. Hydrology is very good. Surveying is good. The mining engineers who fail to take part in courses like mine survey because they think it's not for them. But if you put it all together, there's so much value in the knowledge. And let me also say this, that being a mining engineer, a good one, is not because you learned mining engineering. It's because as you journey through your career, you pick up stuff from different people, work with different people, and learn different things. And when you combine them all, the value is so immense. I think it would be nice to talk about other things more specific in the future. But today, I think this is all the time would allow us to do. There's a question here, contribution by Gideon Okwesi. That's a good one to see. Gideon, good to hear your voice or see you type through here. Every now and then I see your chat on the platform, LinkedIn, so that's good. I want to say that being innovative is a great idea and has nothing to do with being a first or second class. Yes, that is certainly true, Gideon. Thank you. You should think outside the box. Even when you are inside the box, you should be able to think outside of the box. That's very crucial. We must change our thinking and our approach to solving problems. Let's think innovatively and be reasonable, but radical. Yeah, I couldn't agree with you anymore. We need to change the mindset. Imagine when people walk through the city with all these welder-looking screens on top of their faces, saying they're keeping themselves safe from corona. Is there some mindset thing going on there? But we need to think about exactly what we're doing. Anyway, enough of my story. Any more questions? Otherwise, you can throw it to your facilitator. And we could do a Q&A session again on this. This session has been recorded. It would be made available through the coordinator. Please do not distribute to people who did not attend this event because it won't make much sense. You could talk them through it, but you would bear with me that it only makes sense if you were in this session. Thank you.
Hello, doctor.
Hello. Okay. Hello. Can you hear me? Can you hear me?
Yeah, we can hear you.
Okay. All right then.
Yeah.
Thank you so much. I think I had a
Thank you, Gideon. We should connect sometime.
Dr. Isaac, can you share your contact?
Is that Gideon?
No,
Oh,
this is Theophilus from
okay,
Perseus.
so I'll show it briefly. There. But if you go to our website, like these days, you really don't need to ask anyone for contact. You just really do your Google and you find it.
Yeah, like you said, our web browsers here have a lot of limitations. So you search and you really don't find
you
a lot.
get into LinkedIn now, you send a message, it's all good. I'm just
Well,
giving
noted.
you
Sure, that's true.
Okay, so thank you very much, guys. It's been fantastic to have 43 odd people joining today. It was very helpful. And it will be good to have verbal feedback from all of you if I could, but you can pass that on through the platform. I'm on the student platform as well, so we could carry that discussion on your platform if that helps. Recently finished my final year project work on machine learning, where I predicted wet bulb temperatures from dry bulb temperatures, relative humidity. That's good. That's good. It's one thing that you've learned. And if you might just find that by adding this to something else, you may have just come up with some interesting innovation, Anafo. Really good stuff. Any more questions? Are you my session, the meeting room can stay as long as you are ready to stay. For those who would like to chat a bit more later, I could host you for another 30 minutes. So once we formally finish the chat, I can hang around for another 30 minutes. If you have questions, drop it in. And moderator, hello, moderator.
Hello.
Yes, it's up to you now. Would you want us to carry on, or you want to shut it down?
Okay, thank you much. There are no further questions. That was a very enlightening presentation. If there are no further questions, we'd like to move to the next item on the program. That is Mr. Prince Mensah, who would give us the closing remarks. Mr. Mensah is the human resource personnel at Just Mining Limited. So please, if you're available, Mr. Mensah. Mr. Mensah.
Yeah. Hello.
Yes. Hello. We can hear you.
Please. Hello. Yes, madam. Can you hear me?
Yeah, I can hear you.
All right. So thank you very much, Madam Moderator. Yes, a quick correction. I'm actually the Learning and Development Officer at Precious Mining Ghana Limited.
Okay.
And I'd like to thank Dr. Dzakpata Isaac for the wonderful presentation. In fact, I've learned a lot, even as an HR person. I've learned a lot. And it was very, very insightful. Yes, so we have to be innovative. We have to keep standing out as young mining professionals. I keep saying this, when we graduate and we come out, we are always going to compete with students from other universities. You know, so if you're a geology student from Tech who are also engineers, we are always going to compete with them.
You don't have to compete.
What is going to make us stand out?
Yeah.
on the field of job.
Yeah. Okay.
It's always like we are going to meet them on the field. what are we going to do to stand out? It is through some of these seminars and then some of these talks, and then being innovative, keep learning. Okay, so in that we always have to add value to ourselves, and then we be sure to be well-rounded engineers and versatile.
Yes.
So during Doctor's presentation, I saw a bit of economics, I saw accounting. So what I would say is let's not limit ourselves to the engineering field alone. Let's read around. And some of these softwares that Doctor mentioned, research more on them. When we go to see how some of these software, Uber came, the problem solving attitude that Doctor mentioned. So we always have to look at the loopholes, where the box to solve those problems. Okay, so right now you can just sit in your rooms and order for Uber, and then the car will be around, you board it and it gets to your destination. There was this shortage somewhere that someone had to come out with a solution to it. So says we should keep learning, and then we should keep advancing. We should keep adding value to ourselves, and then we can do our internships. We should get mentors who mentor us, okay, and not limit ourselves to the books in quote, because the practical aspect is also very good. And then you work under him, and he's mentoring you. He's pouring all this knowledge in you. It speaks volume. It adds more value to you than, like, say, the book that we limit ourselves to. So I would like to encourage each and every one of us to keep learning and then to keep pushing forward. Like industry, we always want the sharp guys. So just like a normal producer or consumer, we may want to minimize our cost and then maximize our satisfaction. Yeah. How do we do that? We always will look at the sharp guy, the multi-skilled guys. Sometimes HR, we may call them the generalist. You know, the person can do a little bit of everything. So if you're a mining engineer, you don't limit yourself to short-term planning alone. At least you have a knowledge of what geology does, what geotech does, what survey does, and then you know that you are well-rounded so that you can speak to the issues. You know, let's always stand out wherever we find ourselves. And I will encourage each and everyone to join, especially some of these seminars. I want to thank your leaders. They've done very well. When we have students being exposed to some of these things and we get them in the industry, we become very happy, because it is not like it is now that the ways are going to struggle to. I want to thank you very much. And what I will leave you with is, let's keep learning and have problem solving attitude, and let's become tech service. Thank you very much, moderator. I may want to end here.
Okay, thank you very much, Mensa. Okay, so at this juncture, this virtual seminar has come to an end. I would like to thank the management of Awesome Takwa Students Forum for giving me the opportunity for being today's moderator. Special thanks goes to our speaker, Dr. Dzakpata. Mr. Francis Gani, thank you very much. Mr. Prince Mensa, thank you very much. Ladies and gentlemen present, we thank you very much for gracing this. Couldn't have done this without you. Thank you all very much. And then I'd like to say that on the Awesome WhatsApp page, we would put our individual inputs on what we learned there. We can all share it so that maybe somebody missed something. Yeah, we'll all be updated. Thank you very much for honoring this invitation. Yeah, we've come to the end. of this virtual seminar. This is the sixth awesome TAQA Students Forum virtual seminar. Thank you all.